Let's take an example on vertical systems. A 700 kilograms roller coaster car full of people goes around a vertical loop that has diameter of 50 meters. What minimum speed must the roller coaster car have at the top of the vertical loop to stay on track? So diameter is 50 meters. We care about radius. That means 50 over 2. So when the roller coaster is moving with the minimum speed to maintain its circular path, the force of gravity alone is the centripetal force. The track exerts no force on the car in this case. Now, for the roller coaster to stay on track at top of the loop with minimum speed, centripetal force need to equal the force of gravity. To determine the radius of the loop, we find r as 25 meters. We use the equality of the centripetal force and gravity to solve for speed. F net in this case for the free body diagram analysis equals Fg. What we have here as a net forces, we have the centripetal force equals the gravitational force. We know the equation of centripetal force, mv squared over r, gravitational force equals mg. If we take the mass from both sides, that would give you v to equal the square root of r by g, which means square root of 25 by 9.81, which equals 15.7 meters per second. Now let's assume you have a bucket filled with water, and you are holding the bucket through a rope, and the point where you hold the rope is the center of rotation for the bucket. Then you start to rotate your hand so that the bucket will start to rotate around the center. What are the forces affecting on the bucket? In this case, we have the tension force from the rope and we have gravitation force, both pulling towards the center of rotation. Now, centripetal force in this case would be F gravitation plus F tension. As well, when the bucket moved to this position over here, the F gravitation will be always pulling downwards, but the tension always pulling towards the center. So the F centripetal equals the F tension. When the bucket at this point, F gravitation pulling downwards, F tension pulling upwards, centripetal force would equal F gravitation plus the F tension. So the free body diagram analysis here depends on the position of the bucket around the circle. Each point have a different analysis for forces on the bucket, but for simplification we had the top position, side position, and bottom position, and that gave you those explained equations. Now, if we want to summarize the forces affecting object moving in vertical line, firstly, the centripetal force is the net force on the object in any position. Centripetal force determined by the object mass, speed, and radius. In the case of roller coaster and bucket of water, their mass and radius of curvature are constant, so only their speed affects the centripetal force. Force of gravity is one of the forces that may contribute to the centripetal force depending on the curvature and location of the object. Force of gravity remains constant regardless of the position of the object. Now we have a bucket of water, as we mentioned, with a mass 1.5 kilograms in a vertical circle on a rope. Radius of the circle is 0.75 meters. And the speed of bucket is 3 meters per second. What is the tension on the rope in position C? As shown in the figure. Position C is right here. What is the tension? What is the Ft? Do a free body diagram analysis. We have F tension upwards, F gravitation downwards. In this case, we have the F net to equal F gravitation plus F tension, and F net is represented as, in this case, F centripetal equals F gravitation plus F tension. And F tension would be F centripetal minus the F gravitation. F centripetal is mv squared over r minus F gravitation is minus mg, as it is pointing downwards, and your convention downwards to be negative and left to be negative, upwards positive, right is positive. Replace the given numbers, all these numbers are given over here, to find the F tension to be 33 newtons.